Welcome to Fabrity Talks podcast, where we explore software development, generative AI, industrial IoT, and data engineering. Our goal is to provide IT executives with practical business insights that can be seamlessly put into practice in their organizations. You can listen to every episode of our podcast on Spotify, Apple Podcast, Amazon Music, and YouTube. If you want to know more about what we do, visit our website at fabrity.com. Now, let's get started. Welcome to a new episode of Fabrity Talks podcast. I'm Michał Jaskólski from Fabrity, and my job is all about connecting our expertise with the needs of our clients. Today I'm joined by Paweł Garbacz, concept owner at Kemira. Together we'll discuss the technologies that power Industry 4.0. Hi Paweł, thanks for accepting our invitation. It's great to have you here.
Hello Michał, I'm glad we could connect and appreciate the opportunity.
Paweł, could you share more about your professional background and what you do at Kemira?
Sure. I started my career as an SAP consultant, working in systems and integrations technology department, where I was mainly implementing ERPs for our customers and integrating them with other systems. Then after a few years, I decided to quit consultant's life and join a Finnish-based company, Kemira. Kemira is a global leader in sustainable chemical solutions for water-intensive industries. And I took the position of IT global concept owner, mainly for manufacturing, but also source-to-pay and warehousing areas, where I'm responsible for delivering modern IT solutions that help our business to run their operations in more automated and effective way.
Okay, thank you for sharing that background. I think we're heading for the start. So let's start with AI, a hot topic nowadays. What does it mean for you to use AI or machine learning in industrial settings?
Well, so to answer your question, it would be good to shortly define what we mean by AI and machine learning in general. So AI, or artificial intelligence, typically refers to systems or algorithms that are capable of performing tasks that earlier required human intelligence, such as problem solving, decision making, or understanding natural language. And machine
learning then?
Yeah, so machine learning as a subset of AI enables these systems to learn from the data and improve themselves over time without having to be explicitly programmed. Now, you asked about their usage in industrial settings. I think there's a lot of them, starting from predictive maintenance, where data collected by various sensors can be analyzed to discover anomalies that may lead to equipment breakdown, through enhanced quality control with AI-powered image recognition systems, being able to detect product defects on the assembly line much more accurately and more consistently than manual inspection. You may think of process optimization by analyzing historical and real-time data to identify certain inefficiencies and suggest process improvements. You can have more resilient supply chain by using machine learning algorithms that would help you to forecast future demand or optimize your inventories or even streamline your logistics. So basically these technologies can transform industrial operations by enabling smarter decision-making, improving the efficiency, and driving the innovation, which are the goals of Industry 4.0.
Okay, thanks, bro. Thank you for making this strict distinction between machine learning and AI, because I get the impression that everyone is mixing everything regarding AI nowadays. When you talk about machine learning, well, the first things that comes to my mind is predictive maintenance. Indeed, you mentioned that. So could you share your experience regarding this topic? What is your advice? What should be measured? What are the good sensors to start with when thinking about implementing predictive maintenance?
Well, that of course depends on the type of industry that you're in, but I think there is a common starting point, which is the installation of vibration sensors on, for example, rotating equipment, and then analysis of the measured values. Let's take our company as an example.
Yeah,
We are
that would be a good point, really, just to
yeah,
share your experience.
we are a manufacturing company, a process industry company. So obviously in our plants we have a lot of equipment like motors, pumps, mixers, compressors, basically equipment with rotating elements that are likely to fail at some point. For
So
instance,
sounds like a good thing to measure vibrations, really.
exactly, and
Mm-hmm.
and when the I don't know, for instance, bearings were out, the vibration level increases, and
Mm-hmm.
that in turn leads to further imbalance in the system and consequently the equipment failure. So far, typical maintenance strategy for such items was a time-based preventive maintenance. So basically replacing the equipment on predefined time
So
intervals.
everyone does that. It's a classical approach where you got pumped for, I don't know, 10 years or 5 years, and then you have to just replace it.
That's right, that's right. However, this was a
Mm-hmm.
static approach based on the experience of the technicians, and of course, it was always better to be too early with the replacement rather than too late. However, you can see that this was certain inefficiency. And ideally, you would like to know exactly when the pump is going to fail, or at least have some probability distribution that would let you make a more educated, more data-driven decision. So
Mm-hmm.
we decided to employ AI algorithms here that are able to see patterns among vibration measurements data and not only create a notification directly in our ERP when it is needed, but also suggest possible causes like insufficient lubrication or mechanical misalignment,
Okay.
etc. Yeah, this way we can increase the equipment lifetime, of course, but also, what might be even more important, significantly reduce plant downtime, not only by preventing failure, but also unnecessary replacements, and that can heavily affect production output, and also our sustainability goals, as there's less waste generated.
So
And
did you make any tests? I know. How did you know that certain level of vibration is the the one where you need to replace something?
Yes, actually we did, and the prediction accuracy that we were able to achieve is already pretty impressive. During these tests that we did for a pump that was previously replaced every year, we were able to make it work for another few months before the algorithms raised an alert, and after that, it took it around 2 weeks to fail.
Mm.
Yeah, and if you enhance the analysis by adding more data points with, let's say, temperature or fluid pressure, you can improve the accuracy even further. So there is a huge potential here.
Okay, so you literally tested the accuracy of your predictive algorithm in a real world. That is really something interesting to hear about. And this is probably also a good example of tangible benefits that predictive maintenance can bring to the factory. Let's move to large language models. There's a lot of discussion about applying LLMs, to very specific business scenarios, including those related to factory maintenance. At Fabrity, we actually developed a similar solution, a virtual assistant for production department that enables the analysis of data from industrial IoT sensors using natural language processing and powered by LLM. However, LLM, are general purpose models by design. So, how, in your opinion, can these models be implemented in industrial context?
Yes, I had a chance to see your tool, and I must say it looks really promising.
Well, thank you. Good to hear that.
Yes, as you said, LLMs like GPT or Llama are typically trained on wide and diverse data sets. So grounding them in domain-specific data like
Mm-hmm.
equipment, technical documentation, manuals like maintenance logs or historical sensor readings can make them even more reliable. Then using RAG techniques, so retrieval augmented generation, can
Mm-hmm.
reduce their hallucinations and ensure that industry specific terminology is correctly applied so the responses are contextually relevant.
So you're actually feeding them with relevant data and, I know, PDFs and stuff like that.
That's right. That's
Mm-hmm.
right. And after all, you want to build users' trust in the system's recommendations. If you think of practical use cases, then primarily they can serve as natural language interfaces to manufacturing data. So instead of analyzing complex dashboards, you can just ask the virtual assistant questions like, what's the vibration trend for pump A? Or are there any temperature anomalies that increase the risk of failure? The model can then interpret these queries and provide actionable insights that will improve your decision making. It can also help in certain scenario simulation when you ask, for example, what's going to happen if you increase a pump cycle speed by X%.
So actually, technician, we can talk to assistant like like to another human who's very informed.
Yes, exactly. So it can be also very useful in finding the right information in vast documentation that a factory can generate. You won't have to browse through massive amount of usually unstructured data,
Mm-hmm.
but instead a model could classify and extract the essential information that you're able to get instantly. The same way it can be really helpful in trainings and onboarding of new employees, guiding them through different procedures that they should be familiarized
Mm-hmm.
with. So yeah, it is really crucial to tailor the model with domain expertise and local data to make it more than a tool, but rather a proactive assistant.
Okay, that's a very interesting topic. Let's now move to another technology that powers Industry 4.0, and I mean by that industrial IoT. And this is a vast topic, so perhaps we could start with OEE. That's a fundamental measurement that I might even call, a low-hanging fruit when it comes to IoT investments. Yet it provides quite valuable information into how factory operates. What is your experience? What are your thoughts on this?
Well, you're right. OEE, so overall equipment effectiveness,
Mm,
is a
yeah.
fundamental metric and a perfect starting point for implementing industrial Internet of Things solution. OEE measures how effectively your manufacturing equipment is utilized and breaks it down into three key dimensions like availability, so how often your equipment is operational versus planned, then performance, how efficiently the equipment runs compared to its maximum capacity,
Mm-hmm.
and quality, how much of the output meets your quality standards. When you integrate OEE with industrial IoT, this tracking becomes even more accurate and automated. So first of all, you have real-time data collection. So IoT sensors and edge devices collect machine data in real time, eliminating all the delays and inaccuracies that you could have if you chose to enter the data manually.
Mm-hmm.
This means that you always have an up-to-date view on your equipment performance. Then root cause analysis. These platforms can correlate OEE losses like unplanned downtime, reduced speed, or certain defects with specific events or conditions. And
Mm-hmm.
that can help you to identify root causes faster and more precisely. Then lastly, predictive and prescriptive insights. As apart from tracking the historical data, IoT solutions use analytics and AI to predict when the equipment might fail, like we talked before, or
Mm-hmm.
recommend adjustments to improve performance and quality. What is great about starting with OEE linked with industrial IoT implementation is that it delivers practically immediate benefits. It creates a clear return on investment by reducing downtime, increasing productivity, and highlighting areas for improvement.
Mm-hmm.
And at the same time, it lays the ground for more advanced applications from beyond pure OEE area, like sustainability metrics, for example.
Yeah, because no, OEE is just a beginning, and we probably need to underline that Industry 4.0 is about integrating operational technologies, which include hardware, software systems that manage production machinery and devices, with information technologies such as cloud computing, data analytics, your CRM and ERP systems. And the goal is to gain consistent overview of all manufacturing facilities and take data-driven decisions. Could you share with us your experience regarding this integration and other steps behind?
Absolutely. As I mentioned earlier, we are a global company with over 50 manufacturing sites around the world. So we are seeing a great value in having a consistent global overview of manufacturing data across different plants. And therefore, we decided to start a pilot implementation in this area. Integrating operational technology with other IT systems and a cloud platform is at the core of Industry 4.0, and we see it playing a pivotal role in achieving a smarter and more efficient manufacturing processes. First of all, it provides a unified data layer by connecting shop floor equipment with our ERP system, capturing the data in real time and standardizing it for further analysis. Then, using selected cloud solution, our manufacturing people can monitor, visualize, and control operations across multiple facilities. And lastly, by integrating advanced analytics and machine learning capabilities, the business can derive actionable conclusions, identify bottlenecks and optimize production schedules. In a longer perspective, we see a potential in this system as a single source of truth for all production activities, giving an end-to-end visibility and monitoring capabilities for key metrics like OEE, energy consumption, or production yield.
Well, that sounds really like a lot of data if you've got 20 facilities and you're integrating all the data from all these facilities to gain insight.
Absolutely. But
very impressive.
But it can also be or act as an enabler for early detection of equipment anomalies, again, minimizing downtime and other disruptions in production. Then also scalability is important for us as our sites vary in size and complexity. So having a platform that standardizes reporting across them all makes it much easier to benchmark performance and implement best practices.
So if we're talking about lots of data, another thing that comes to my mind is a digital twin concept. It's another strong concept behind Industry 4.0. So what are the opportunities? What do you see in digital twin for enhancing plant management and operational efficiency?
Well, especially in manufacturing, but not only, digital twins unlock huge potential for enhancing operational efficiency and plant management because they serve as data-driven dynamic virtual models, or replicas as they are often called, of physical assets or systems or even processes. They allow manufacturers for simulating production processes in digital twin to test the changes or improvements such as reconfiguring assembly lines, adjusting certain machine parameters or optimizing workflows without
So actually you can sorry for interrupting. So actually you can run tests before actually making any investments, parameters, or even introduce new machines into the factory.
Exactly. They provide a virtual environment where operators can practice tasks or learn new equipment without affecting production, and that enhances both safety and skill development. They can help to monitor and optimize water usage, material flow, or energy consumption, again, contributing into cost savings and sustainability goals. Speaking about safety and sustainability area in general, what always comes to my mind when I think of digital twins is the Chernobyl disaster.
Oh,
yeah, you can imagine
that's
yourself
interesting.
how.
Just to explore that.
Yes. So things would really go differently if the famous RBMK reactor had its digital twin back in the day, and the twin would have been used to run the experiment that ended as we all know. But then many times mentioned predictive maintenance, another perfect example where maintenance teams can address the issues proactively, reducing the downtime and maintenance costs. Modeling factory layouts and production capacities, another place where it can support better planning for expansions, new equipment installations, or shifts in production demand. So it's really hard to list all of the potentials that lie in digital twins.
Well, that's a thrilling idea of having digital twins since then, but we know that would be absolutely impossible for them in their technological advancement level these days. But yeah, probably that would save lives if that would be possible. So another even probably more futuristic is augmented reality. And much has been said about AR glasses and their potential in many areas of life. But let's focus on how they can help, for example, maintenance technicians to speed up their work. Do you have any use cases where AR glasses were used and that could streamline tasks?
Well, definitely, as you said, they can be very useful for maintenance technicians, as they can display repair or installation instructions for the equipment directly in their field view, or even they can get a remote support from the manufacturer's expert side. But their potential extends beyond maintenance. In the manufacturing context, you can think of process monitoring and control, for instance, where AR glasses allow the operators to monitor certain production parameters and overlay them in real time on specific equipment or pipelines. That
Mm-hmm.
can minimize the risk of process deviations. They can identify or highlight certain areas in the manufacturing site where the entry requires to wear protective gear, for instance, so they can ensure the workers' safety. Then in the warehousing field, our glasses can assist the workers with picking the right pallets by displaying their exact locations or optimizing routes or provide
Mm-hmm.
instant updates on the inventory levels, which again can increase their efficiency and reduce errors in that area. You can think of quality inspections augmented with overlaid criteria that help to identify defects. So basically, any
Okay.
contextual, real-time, hands-free information can find its usage to improve the efficiency in one area or another.
Yeah, so actually a lot of these use cases where nowadays we use or got used to using computer vision now can be moved to glasses and do even more with that on the field, really, with people looking through the glasses. Okay, so last but not least, cybersecurity. So what are cybersecurity threats for industrial networks? Well, empathizing, of course, IoT networks.
Oh yes, that is a really important aspect as well. Industrial control systems or operational technology in general has traditionally been much more isolated, yet they were still a rather soft target for the attackers.
Mm-hmm.
Due to their isolated nature, they were often lacking basic safeguards or protections like even automatic antivirus software updates. Now, when they are increasingly connected to IT networks or the cloud, they are exposed to a whole set of new threats. Let's take ransomware as an example. So a software that blocks the access to your data or critical systems until a ransom is paid. Modern factory operations depend on constant availability of systems like SCADA or MES. And
Mm-hmm.
if the operators are locked out of these systems, it can easily lead to halting the production. Value of data in present days is hard to be overestimated, and it is not different in a manufacturing context. Ransomware attacks can block you the access to your data on one hand and leak it outside on another. So also safety can be compromised, especially in sectors like chemicals. If the operators lose control on their systems, the operating conditions may very quickly become unsafe, which increases the risk of accidents, spills, fires,
Explosions and so on and so forth.
explosions. So it really doesn't take much imagination to see how severe the consequences of such events can be, and that they can easily come at greater cost, both financial and reputational, than typical IT network failure. So it is absolutely critical to develop preventive measures for these situations, such as offline stored, regular encrypted data backups, network segmentation to limit potential spread of ransomware, or regular software patching and updates, especially in legacy systems often found in industrial environments. However, no matter how integrated and automated the systems are, it is still often a human that plays an important role here and maybe a weak point. So educating your staff about phishing techniques and social engineering tactics still remains vital. And well, last but definitely not least, no matter how happy you are with all the countermeasures that you have taken, always prepare a solid contingency plan. Don't
And that's
ever,
always true, isn't it?
yeah. I mean, don't ever underestimate your adversaries, as they can be really good in their job as well.
Great. Okay. Well, thank you very much for sharing your insights regarding IoT Industry 4.0 and all these advanced ideas about glasses and cybersecurity. I think that's all that we have for today. So thank you for being our guest.
Well, thank you, Michał, for having me. Appreciate it and glad to share.
So thank you for listening, and until next time. Bye-bye.
Bye.
Fabrity specializes in bespoke software development, generative AI, industrial IoT, and data engineering. We build complex solutions for enterprise clients to automate processes, boost efficiency, reduce downtime, and enhance decision-making through effective data analysis. If you have a software project in mind or any questions, feel free to reach out at sales@fabrity.com. And if you have a topic you'd like us to cover or want to join the conversation on Fabrity Talks, we'd love to hear from you. Thanks for listening, and until next time.